Perhaps the most widely known piece of equipment at the National Weather Service is the Doppler Radar, or as many folks refer to it as, the giant soccer ball. The Doppler radar stands nearly 125 feet tall and is built to withstand 150-mile-per-hour winds. Inside the ball is a large satellite dish which is turning all the time, 24 hours a day. It does a complete 360-degree revolution at an elevation of a half degree, then tilts up a little bit and makes another revolution. It does this until the last and highest elevation turn is made before dropping back down to the half-degree elevation for another round of revolutions. This whole process from the half-degree elevation sweep to the highest elevation sweep is called a volume scan. Now, the radar works by sending out pulses of energy during each turn, and then waits to see if it hits anything, such as raindrops, snowflakes, and hail. If it does hit something, some of the energy is sent back to the radar. The amount of energy returned is calculated, as well as the amount of time it took to make it back. This data is then processed at the buildings beneath the radar, and then sent into the actual National Weather Service building to be processed again, and ultimately displayed at our workstations. We can then determine the intensity of the precipitation and the distance the precipitation is away from the radar, which could be as far as 150 miles away. What makes the Doppler radar so special is that it can see the motion of the precipitation within the thunderstorms, which is also the air motion. It sees whether or not the motion of air is directed toward or away from the radar, and this is critical for identifying the potential for tornadoes and other severe storms. What may not be as well known is that the Doppler radar can be set in different modes. For instance, we can make the radar take additional 360-degree sweeps in the volume scan in order to dissect the atmosphere or storms in greater detail. Another interesting thing about the Doppler radar is that it can be set to a very sensitive mode, which can actually detect dust and other particulates in the atmosphere, insects, migrating birds, and converging areas of wind such as lake breezes, which are so common here in northern Michigan. The National Weather Service's Doppler radars were positioned strategically across the country to provide the greatest amount of radar coverage for the United States population. And not so surprisingly, these Doppler radar positions are also where most of the National Weather Service offices are located.